Hi, this is Mrs. Moret with help on today's assignment from Unit 2, Lesson 22. This is in your textbook on page 225 through 227, and you're doing numbers 1, but only problems B through D in there. Also number 3, but only A and B on number 3, as well as number 5 and number 6. So let's get started. So today's lesson was about solving a little bit more complex rational equations. And one of the things you had to pay attention to is when you're solving, are there certain values for x that you wouldn't be able to use in the original equation? Remember, those are called extraneous solutions. They're solutions that you come across by doing legal moves to solve an equation, but then it doesn't actually work, even though you get to it, like I said, using what we sort of term legal moves in equation solving. So I'm going to zoom in. We'll start on problem B. Okay, so using our same strategy of eliminating the fractions in the problem by multiplying by the denominators, we'll start with that. But before we do any of that, I'm just going to write down the values of x that would make either of these denominators equal to 0 so that I remember that when I'm going to state my final solutions. So I know here x cannot equal -2 or 1. And I'm just going to do C and D as well. On C, it's actually the same thing. So if x were 1, that would make the denominator equal to 0. And here, if x were -2. So same restrictions on C. And then on D, it's -8 and -2. Okay, so those are just like reminders so that we can check that if one of those numbers does end up appearing to be a solution. So on B, we're going to start by multiplying both sides of the equation by x plus 2 times x minus 1. And on both sides. Okay, so on the left side, that eliminates the x plus 2's. On the right side, it eliminates the x minus 1's. And I'm going to go ahead and distribute. So for the left, we get x minus 1 after we're just distributing a 1. And then that equals 2 times x plus 2 times 2, so 2x plus 4. And then we'll just solve. So I'm going to subtract the 2x from both sides and add the 1. So that cancels there and cancels there. And x minus 2x is -1x. 4 plus 1 is 5. So divide. X equals 5. And since that's not one of the restrictions on x, this is the solution. Okay, moving on to C. I notice on C, I still have 2 different denominators, so we're going to multiply both sides of the equation by those denominators. And so I'm going to multiply by 1 minus x times x plus 2. And over here, I'm going to multiply by the same thing, 1 minus x times x plus 2. And so that cancels the 1 minus x's. And over here, it cancels the x plus 2's. And so what I have is x plus 2 times x plus 3 equals 1 minus x times x plus 1. Okay, So I have two sets of binomials that I need to multiply out. And so I think I'll just use the column over here to do that. So I have some space there. And so x plus 2 times x plus 3. That's x squared, 2x, 3x, and 6. So the left side of the equation is equal to x squared plus 5x plus 6. And on the right side, 1 minus x times x plus 1. So this is x1 negative x squared and negative x. And so altogether, it's negative x squared, and then that's x and negative x, that makes 0. So negative x squared plus 1. All right, so since I have a quadratic, I'm going to go ahead and add over the x squared and subtract the 1 on both sides so that it's equal to 0, because to solve a quadratic, the first step is to make it equal 0, and then you can decide whether you want to factor or use the quadratic formula. So I'm going to add over the x squared and subtract the 1 and line those up with their same kind of term on the other side. And so you can see we have 2x squared plus 5x plus 5 is equal to, this is 0, so altogether 0. So now we need to factor 2x squared plus 5x plus 5. And so to do that, I'm going to use a factor box. I'll put it over here. So basically, I want two factors so that I can then solve them individually. All right, so to factor this, we're going to put our first term here, 2x squared. Our constant goes down here, 5. And then we multiply them together. And we get 10x squared. And what multiplies to 10x squared and adds to 5? Okay, so they have to multiply two numbers that multiply to get 10x squared and add to get 5x from the middle. And I've been thinking about this, and I realize that there isn't a combination that will do that. There isn't a combination of values that will multiply 10x squared and add to 5x. So our other option for a problem like this is the quadratic formula. Now, this quadratic formula, I'm expecting you can use it on your homework with a little bit of help. I would not put a problem on your assessment that would require you to use the quadratic formula. So don't worry about that too much. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so a is 2, b is 5, and c is 5. It's probably been a while since you've used this formula, but one of the things that I always have kids do right away is I have them figure out the discriminant. So b squared minus 4ac. So that's 5 squared. B is 5. A is 2, so 4 times 2 times C is 5. Okay? And so the reason why I have you do this first is because sometimes that ends up being a negative number. And negative numbers, we can't take the square root and get a real answer. So minus 4 times 2 times 5. And look what happens. We get negative 15. So this part of the quadratic formula is going to be the square root of a negative number. And so to set it up all the way, I would say x equals negative b, and b is 5, plus or minus the square root. Instead of putting that all in, I'm going to put the answer because I just found on my calculator that this was negative 15. All over 2a, and a is 2. So 2 times 2. Okay? And so if I was to put that into my calculator, watch what happens. If I put in, get these both in the window so you can see. Okay, remember alpha y equals enter will give us that nice fraction. So negative 5 plus the square root of negative 15 over 2 times 2. My calculator says error, non-real answer. Oh, it's because I've got a negative under the square root. Well, what if I subtract? Maybe that'll give me. Let's try subtracting because we already did plus, and it's plus or minus, so you do it 2 times. Actually, alpha y equals enter. Negative 5 minus the square root of negative 15 over 2 times 2. I get an error message again. So problem C really and truly has no solution. And that time it didn't even come from like finding solutions and using legal moves and then seeing that one of them doesn't work. This has no solution because there's a negative number under the square root. Okay, last but not least, on number 1, problem D. So on problem D, we're going to multiply both sides of the equation by x plus 8 times x minus 2. And squeeze it in over here as well. Okay, so on the left side, the x plus 8s cancel each other out. And I think I have room here. I have x plus 2 times x minus 2 equals, wait, sorry, this should be a plus, this should be a plus, this should be a plus. Okay, back in action. On this side, the x plus 2's are eliminated, and I have 1 times x plus 8, which is simply x plus 8. Okay, so now I just have to multiply this part out. I'll make one more little box here. X plus 2 times x plus 2. That's x squared, 2x, 2x, and 4. So altogether, x squared plus 4x plus 4 equals x plus 8. And then we'll use that same strategy because it's quadratic since the highest term is x squared. And we're going to subtract both of these terms so that we have a 0 on the right side. And line them up under their appropriate term. And we'll see, so we definitely get a 0 over here. And then this is x squared, 4x minus x is 3x. And 4 minus 8 is negative 4. Okay, so now we'll try and factor this quadratic and see if we can get something that works. So use my little factor box. The x squared goes here, the negative 4 goes here, and then if you multiply them together, you get 4x squared. And then, so we're looking for numbers that multiply to 4x squared, sorry, negative 4x squared, and add to 3x. So I think I'm going to use 4x and 1x. And one of them needs to be negative. I will have the 1x be negative, so it adds up to positive 3x. Okay, and then this is always, the x comes out here and there. We need a -1 and a +4. So it looks like x squared plus 3x minus 4 is equal to x plus 4 times x minus 1. And so finally, if x plus 4 equals 0, x equals -4. And if x minus 1 equals 0, x equals +1. X equals -4 and x equals +1. These were the restrictions, so these are good answers. All right, let's move on to number 3. That was a long problem. We're just doing A and B on number 3. And so here we go. So the first thing we're going to do here again is we're going to identify the restrictions on x. So here's an x in the denominator. If it were simply equal to 0, we would have a problem. So that's our restriction on A. It's the same as the restriction on B because the only denominator is right here. The only fraction is right here. And same with here. Okay? So on A, we're going to multiply both sides of the equation by x. And so we get x squared equals 25. We had a similar problem in a warm-up the other day, and we talked about how when you square root to solve like x squared equals, you have to remember to take the positive and the negative square root of 25. So x is equal to positive or -5, which is not 0, so this is a good solution. One more time, just to remind you why we have the positive and the negative. X squared is a parabola. It has its vertex is at 0, 0, and y equals 5 is a horizontal line. And so here's where it crosses at +5, and here's where it crosses at -5. So that's why this has two solutions. All right, on problem B, we are also going to multiply both sides of the equation by x, but let's remember that's a quantity. So when we multiply it by x, we need to distribute. These x's are eliminated. X times x is x squared. X times 2 is 2x, and that is equal to 6x minus 3. So again, we have a quadratic because this starts with x squared. And so we're going to move the 6x minus 3 to the other side using the opposite operation. So minus 6x and plus 3. And minus 6x can go right there. There isn't a constant. I'm just going to write the plus 3 right here and then write out the rest of the equation. This is 0. X squared, that will be minus 4x and then plus 3. And we actually factored the same exact quadratic on problem D from number 1. And so I'm not going to go through the steps of factoring again. Wait, did we? Oh my goodness, I'm so sorry. It's actually like really close, but not quite the same. So I will go through the steps of factoring. Okay, so we'll just fill in these blanks. All right, so here's the little factor box. And x squared goes here, positive 3 goes here. Multiply them together. We're looking for factors of 3x squared that add up to -4x, the term in the middle. And so I know 1 times 3 is 4. Since this is positive, they both have to be the same sign. And since they have to add up to a negative, they both have to be negative. Like that. All right, so the GCF of the top row is just x, which means we need another x there. And we need a -3 here and a -1 there. So x minus 3 times x minus 1 is equal to 0. So again, we're going to find those two solutions. The only restriction is that x can't equal 0. So x minus 3 equals 0. X is equal to +3. X minus 1 equals 0. X is equal to +1. And they both are true solutions. All right, number 5 is a rearranging formula or problem. So we want to just rearrange this formula here to get it into this form. And we do that by just dividing each term by the denominator. So we'll start with dividing each term by x. So x divided by x minus 9 divided by x. That's our first step. X divided by x is equal to 1. So our final answer is 1. And then 9 divided by x will just stay 9 divided by x. So g of x equals 1 minus 9 divided by x. And just as an FYI, this 1 right here is a horizontal asymptote at y equals 1. And that's the reason why we would go from this form to this form, just so that the asymptote is more obvious. All right, number 6, Elena has a boat that would go 9 miles per hour in still water. So 9 miles per hour in still water, that is like the speed of the boat. She travels downstream. So remember, downstream, the speed of the river is making her travel faster for a certain distance and then back upstream to where she started. Elena notices it takes her 4 hours to travel upstream, but 2 hours to travel downstream. The river's speed is r miles per hour. Write an expression that will help her solve for r. So we don't actually have to solve this one, but let's look at the important information. So like I said, this is the speed of the boat. She travels downstream for a certain distance and then back upstream to where she started. It takes her 4 hours to travel upstream and 2 hours to travel downstream. And then the river's speed is r. So keeping in mind the little distance formula, distance equals rate times time. Going upstream, it takes her 4 hours. That's the time. And the rate is going to be the 9 of her boat minus the speed of the river because it's slowing her down. So upstream, we can say the distance equals was 4 hours and 9 minus r because it slows her down. Whereas going downstream, the distance is equal to, it only took her 2 hours because the river was speeding her up. So 9 plus r. Now, the distances are the same. She went downstream and then she went back upstream to where she started. So those are equal. So the expression that will help her solve for r, we can actually write an equation. 4 times 9 minus r equals 2 times 9 plus r. All right, and that is the end of your assignment. I hope you found this helpful.